Hello dear students, I am Pratima. I welcome you all to this video. So today we will go for trigonometric identities, how it can be simple so that you won't feel difficult to prove an identities. I am starting from very basics. So don't worry, if you will go on writing and understanding, I am sure that you will be confident in the examination. So trigonometric ratios are applied for right triangle only. So here ABC is a right triangle and this angle is 90 degree. Opposite of 90 degree we call hypotenuse. So AC is hypotenuse here. If C angle is denoted by theta, theta means it is a Greek letter, it is represent your angle. Opposite of theta is your perpendicular and adjacent to theta is called your base. So perpendicular we denote P, base or adjacent we denote B, and hypotenuse always we denote H. And you know the trigonometric ratios. If you don't know, no problem. You write down. First is one trigonometric ratio is sine theta, sine of this angle. So this is a ratio of perpendicular AB to your AC, perpendicular by hypotenuse. This ratio of these two sides we call sine of theta. Similarly, ratio of B and H, adjacent and hypotenuse, we call as cos theta. Next is third, tan theta. It is perpendicular by base. That means if you measure AB, measure BC, you will take a ratio. That constant is called tan theta. Similarly, if you will take base BC upon AB, you will find a constant ratio for any angle. We call it as cot theta. So these are the not aliens, only to a ratio we are giving a name, cosec theta, h by p. If we take ratio of h, hypotenuse and perpendicular, we call cosec theta. Similarly, if we take ratio of hypotenuse and base or adjacent of this theta, we name as sec theta. So these are the new names which you are not familiar till your class 9. Now you are learning these 6 new terms. What is theta? Theta is an angle. It can be 40 degree, it can be 30 degree, it can be any angle. But this ratio is always constant. If you measure the sides and take the ratio, take the fraction, it will be always constant and we have named it. Sin theta, cos theta, tan theta, cot theta, cosec theta, sec theta. Next, we'll make some relation among them. Can you find a relation? You see cosec sin theta is P by H, cosec theta is H by P. So are they related? Yes, one is reciprocal of other. So sin theta and cosec theta will be reciprocal to each other. In the same way, see cosec theta, cos theta and sec theta. One is B by H, one is H by B. So I can make a relation. Next, tan theta and cot theta. Tan theta and cot theta. Tan theta is P by B, cot theta is B by B. So one is reciprocal of other. So now I can make into 3 pairs, 6. I can make 3 pairs. So from this, we are making pairs. First is tan theta is equal to 1 by cot theta. Or cot theta is equal to 1 by tan theta. So these are the one pair. Out of 6, I made a relation. Or I can write tan theta by sin theta by cos theta. See sin theta is equal to P by H, cos theta is equal to B by H. So if we'll divide P by H by B by H, what you are getting? You are getting P by B. P by B is nothing but your tan theta. So sin theta by cos theta is tan theta. So similarly, what will be cot theta? Just opposite of it. Cos theta will be the numerator. Sin theta will be denominator. So you find another relation. This relation you have to keep in mind to solve the questions. Next is sin theta is 1 by cosec theta. We have already discussed. One is reciprocal of other. So I'll write cosec theta is equal to 1 by sin theta. Now what next? Second cos, sec theta, cos theta. Cos theta is 1 by sec theta. Sec theta is 1 by cos theta. So many relation you have to write down in a copy, or you have to keep on remembering. Next, coming to, after knowing all this relation, all this, that means rules, now I'll go for identities. What is identities? Identities is a relation which is always true. You know, if you have read in algebra. Now we'll go for trigonometric ratios. For that, we should know the relation between your heads of the right triangle using your Pythagoras theorem. You know that p square plus b square is equal to h square. In a right triangle, your sum of square of two sides is always square of the hypotenuse. So this relation is very important here. Without relation, we cannot prove identities. When p square plus b square is h square, from this, if I'll separate p square, how much it will be? It will be h square minus b square. B square will be subtracted here. So you have to remember this also. Similarly, what will be b square? B square will be h square minus p square. So whenever you see, we have to convert to other form. We have to keep these three relations in your memory. Next, we'll go for identities. First identity is sin square theta plus cos square theta is 1. For a identities, sin square theta plus cos square theta is called left hand side of identities, and 1 is called right hand side of identities. For an identities, you can start from left hand side, you can reach in right hand side, you can start from right hand side, you can reach in left hand side, or you can proceed little bit from left hand side, proceed little bit from the right hand side, and make them equal. You can proceed in any way. So, but most of the times we do from left hand, we reach at RHS. When there is a problem, we can start from RHS. But there is not hard and fast rule to start from LHS. So here, first identities is the most simple identities I am writing to prove, and which is also applied to other complicated identities. To prove, we use this. So sin square theta plus cos square theta. So what I'll write? I'll write LHS. That means left hand side. Sin square theta plus cos square theta. Sin square theta means it is same as your algebra if you apply. This is sin theta whole square and cos theta whole square. And what is sin theta? Sin theta is p by h, its square. What is cos theta? P by h square. Now I'll write p square by h square plus b square by h square. What is LCM? LCM is h square. What will the numerator? P square plus b square. Next, recall the formula p square plus b square. Pythagoras theorem. What it will be? H square. This you have to remember. Otherwise, you cannot do it. So this will be h square by h square. How much you are getting? You are getting 1. So this is your RHS. So it is proved. So we could prove one identity. Now we proved this sin square theta plus cos square theta is 1. From this, I am deriving two more identities. What? I'll separate sin square theta. Then how much it will be? Cos square theta will be subtracted here. So instead of sin square theta, I can write 1 minus cos square theta when I need it. I need to convert sin to cos. Similarly, if in want to change cos square theta to sin square theta, I'll write 1 minus sin square theta. So these are the two more relations we are getting from one relation. So identity is 1, we proved. Second, I'm going for sec square theta minus tan square theta is 1. This is second identity. So what is LHS? LHS is equal to sec theta square minus tan theta square. Immediately you will recall what is sec theta. Sec theta is equal to h by b. And tan theta is equal to p by b. Make it square, both the numerator and denominator. H square by b square minus p square by b square. Take your LCM, b square. It will be h square minus p square. Now recall the fact. H square is equal to p square plus b square. So if I'll subtract h square minus p square, how much I'll get? I'll get b square. So this will be b square by b square. B square by b square, certainly it is 1. So this will be your RHS. Are you getting 1 right hand side? Yes. So hence proved. So from this identity, I can get other identities also. What is it? Previously we have got this. Now I am adding. One is sec square theta minus tan square theta is 1. From this, I'll separate sec square theta. Then tan square theta will be added here. So this one, the another identity. If you want to separate tan square theta, how much it will be? It will be sec square theta minus 1. So we got so many relations and you have to keep it in memory. You have to remember this to solve more questions. You can note down next third identities. It is cosec square theta minus cot square theta is equal to 1. I am starting from LHS. I hope you are able to do now. This is cosec theta square minus cot theta square. Cosec is h by p. Cot is your b by p. So this is h square by p square minus b square by p square. P square is the LCM. H square minus b square. S square minus b square is p square. P square minus p square is equal to 1. So are you getting h square minus b square? If followed, this is p square. We am applying this one. So this is your RHS. So hence proved. So we got cosec square theta minus cot square theta is equal to 1. So if I'll separate cosec square theta, I'll get this is 1 plus cot square theta. If you want cot square theta, I'll take to right side, then it will be cosec square theta minus 1. So we are getting two more relation from it. So we had learned 6. Now I'm adding cosec square theta minus cot square theta is 1. Cosec square theta is 1 plus cot square theta. Cot square theta is equal to cosec square theta minus 1. So these are your tools which will be applicable for proof identities. So I'm coming to question number 5, which carries 10 identities questions. Prove the following identities where angles involved are acute. You have to prove cosec theta minus cot theta whole square is equal to 1 minus cos theta by 1 plus cos theta. Again, I have to remind you, for identities, you would need all the algebraic relations, algebraic expressions. algebraic identities. You need all the algebraic identities, all the formula. So starting from this, where I'll go left hand side. This is left hand side, this is your right hand side. So first cosec theta minus cot theta whole square. We feel identity is difficult because these are the new terms to us. But if you will convert this into sine cos and you will remember the basic relation, it won't be difficult. Of course, you have to be expert or confident in algebraic identities. Algebraic identity means a plus b whole square, a minus b whole square, a square minus b square, then only you can do. So cosec I am writing as your 1 by sine theta. And cot theta I am writing cos theta by sine theta. So whenever I observe that right hand side cos is there, so I'll convert this left hand side in sine and cos. So this will be 1 by sine theta, cosec theta I wrote, cot theta I wrote, cos theta by sine theta. Why I am converting? Because in right side there is cos term, no cosec, no cot. So I am converting this into sine and cos. Next, inside the bracket, I'll simplify because I'm getting numerator as your sine theta, denominator as sine theta. So this will be LCM. And here I'm writing 1 minus cos theta in the numerator on simplification within the bracket, within the square. I hope it is followed. Next, what I'm writing, I'm not squaring. I'm writing in this way. That means anything square means that is same thing multiplied 2 times. So I'm multiplying 1 minus cos theta multiplies 1 minus cos theta. And here also I'll multiply sine theta into sine theta. Then it is 1 minus cos theta multiplies 1 minus cos theta. I'm not multiplying. Now question is why I'm not multiplying? Because in always observe your right hand side. Here it is 1 minus cos theta. That means I'm getting 1 minus cos theta. No need of squaring or expanding. Here in the denominator you are getting sine square theta. And see the RHS right hand side, there is no sine square theta, no sine theta. That means I'll convert sine square theta as your cos. What is the relation? If you recall, this will be 1 minus cos square theta. So I'll write 1 minus cos theta multiplies 1 minus cos theta. And this sine square theta, I'll write 1 minus cos square theta. Next, I'll go for algebraic identities. What is it? A square minus b square is equal to a plus b multiplies a minus b. So I'll write 1 minus cos square theta is equal to 1 minus cos theta into 1 plus cos theta. So immediately you can recall this, then only you will feel easy. So in the next step, I'll write 1 minus cos theta into 1 minus cos theta, and the denominator I'll split into factors. 1 plus cos theta multiplies 1 minus cos theta. Can you find same thing on the numerator and denominator? This two will be cancelled. What you are getting? 1 minus cos theta in the numerator, 1 plus cos theta in the denominator. Are you getting the same thing as RHS? Yes. So hence proved. Next, I'll come to a similar question where there is a plus. Similar question, I'll go for a similar way. But I'll write cosec theta plus cot theta whole square, so that you will have a practice, you won't forget it. So I'll write 1 by sin theta plus cos theta by sin theta whole square. Then what I'll do, I'll simplify within the bracket. I've already shown 1 plus cos theta whole square. Then what I'll write 1 plus cos theta multiplies 1 plus cos theta, and this I'll make it sin square theta, sin theta into sin theta, sin square theta. In the next step, I hope you are following, I'll make into 1 minus cos square theta. I have already written the first question. Sin square theta is equal to 1 minus cos square theta. Why? In the right hand side there is no sign, so I'll change. So 1 plus cos theta into 1 plus cos theta upon 1 plus cos theta into 1 minus cos theta. This algebraic identities I applied, a square minus b square. What will be cancelled? Plus will be cancelled here. So what will be the answer? Answer is 1 plus cos theta by 1 minus cos theta. Are you getting same thing as RHS? Right hand side? Yes. So hence proved. So from one question, you will want another question. Let us change the question little bit. I'll frame another question, similar identities, but this sec theta minus tan theta whole square is equal to 1 plus sin theta by 1 plus sin theta. This is another question, but with the same pattern. So what I'll do, I'll change sec theta. What is sec theta? 1 by cos theta. What is tan theta? Sin theta by cos theta whole square. Why I am changing? Because on the right side there is no sec tan. Then I'll write, it will be cos theta 1 minus sin theta square. Then same pattern you will go, 1 minus sin theta into 1 minus sin theta. And what about cos theta? It will be cos square theta. What I'll do, I'll change the cos square because in the right side there is no cos. So it will be 1 minus sin theta into 1 minus sin theta, and the denominator I'll write, it will be 1 minus sin square theta. Then I hope you are understanding what will the next step. Next step I'll put the algebraic identities. 1 minus sin square theta means 1 square minus sin square theta. I'll write 1 plus sin theta into 1 minus sin theta. What will be cancelled here? These two will be cancelled. What will the answer? 1 minus sin theta upon 1 plus sin theta. It is RHS? Yes. So hence proved. So what will be its alternative? It will be sec theta plus tan theta whole square is equal to 1 plus sin theta by 1 minus sin theta. You try to do yourself, pause the video and try to solve yourself. Try to solve yourself so that you can develop confidence. So it will be 1 by cos theta plus sin theta by cos theta whole square. Pause the video, then only you check the answer. 1 plus sin theta upon cos theta whole square. This will be 1 plus sin theta into 1 plus sin theta. It will be 1 plus sin theta into 1 minus sin theta. So the answer is 1 plus sin theta by 1 minus sin theta. This is equal to RHS. Next I am coming to question number 2. So we have finished all these parts. Let me summarize. From 1, you can do all these 4 questions. When the same pattern you will go, you can learn all 4 questions. Next is question number 5, question number part 2, cos A by 1 plus sin A plus 1 plus sin A by cos A is equal to 2 sec A. As I told earlier, what is all your algebraic concept is here. That means you will simplify the rational expression. Simplify rational expression as do in algebra. As algebra. Then apply trigonometric relations. So LHS will be just your denominator. I'll take this your LCM. That means I'll multiply these two as you do. Suppose you do A plus B by C by D. What do you do? We do BD is the LCM. Du is multiplied in A and B is multiplied in C. Same concept here. Cos will be multiplied with cos A and 1 plus sin A will be multiplied with 1 plus sin A. I repeat, first I took the LCM of these two. This is same just product because one is not factor of other. Cos A is multiplied with cos A and 1 plus sin A is multiplied with 1 plus sin A. I'll simplify now. Cos A into cos A, cos square A. Cos square A we write in this way, or we can write this is same as your cos A whole square, meaning same. It will be cos square A. Now I'll multiply 1 plus sin A into 1 plus sin A. 1 into 1, 1. 1 into sin A plus sin A. Sin A into 1 sin A. Sin A multiplies sin A, sin square A. Or you can make it 1 plus sin A whole square. That will be also same result. So this will be 1 plus sin A into cos A. So how much it is now? I'll need simplification. So I'll write cos square A, sin square A together and I'll make a group. Why? Can you guess? Because you know that cos square A, sin square A makes you 1. So it will be simplified. Plus 1 and sin A together gives you 2 sin A. And whole divided by 1 plus sin A into cos A. So what I'm getting now, in place of this, I'll get 1 plus 2 sin A whole by 1 plus sin A into cos A. So this is your 2 plus 2 sin A. 2 plus 2 sin A as a algebraic identities, you can take 2 common. Take 2 common. What you are getting? You are getting 2 common 1 plus sin A. And in the denominator, there is a 1 plus sin A, which will be cancelled. This 2 will be cancelled. What you are getting? You are getting 2 by cos A. So 2 upon cos A can be written as 2 into 1 by cos A. What is 1 by cos A? It is sec A. Why I am writing sec A? Because see the right hand side now. It is just simple terms 2 into sec A. That means I'll write 1 by cos A as your sec A. So 2 sec A. So this is your RHS. Hence proved. You can pause the video, you can copy it down. Question number 3. 5. Question number 3. Tan theta by 1 minus cot theta plus cot theta by 1 minus tan theta is equal to 1 plus sec theta into cosec theta. Hint is given. Write the expression in terms of sin theta and cos theta. Okay. So LHS start from tan theta by 1 minus cot theta plus cot theta upon 1 minus tan theta. So as hint is given, I'll write your tan theta is sin theta by cos theta upon 1 minus cos theta by sin theta plus cot theta is cos theta by sin theta upon 1 minus sin theta by cos theta. So you are getting a complicated expression, but have some patience and do it as you do in algebra, it will be fine. First I am doing this denominator because it needs more simplification. And sin theta by cos theta, numerator part I wrote, denominator I am simplifying. Sin theta is LCM. Here 1, sin theta will be multiplied with 1 sin theta minus cos theta plus here cos theta by sin theta is the numerator. I am simplifying the denominator. Here cos theta will be the LCM. Cos theta will be multiplied with 1 cos theta minus sin theta. Next simplification. Next what I'll do? I will writing in this way. A by B by C by D is same as your A into D by B into C. So this sin theta will be multiplied with the numerator. So I'll get sin square theta, and this cos theta will be multiplied with sin theta minus cos theta. And for the second one, cos theta will be multiplied with the numerator. As I do, D is multiplied with A, B is multiplied with C, so cos square theta, and here it will be sin theta multiplies cos theta minus sin theta. One part is completed. Next again simplification. Now when you will simplify, now take care of this LCM. What will be LCM? Here it is sin theta, cos theta, that it can be written. Sin theta term is also there, cos theta is also there. Now what about this? Sin theta minus cos theta minus sin theta. Are they same or they are different? They will both will be written. Here people make mistake. Here if you will see, one is sin theta minus cos theta, one is cos theta minus sin theta. If you think one is A minus B, one is B minus A, they are not different. How they can be make same? If I'll write A minus B, and from this B minus A, if I'll take a negative sign common, then it will be A minus B. That means one is negative multiple of the other. So I'll write sin theta minus cos theta, and you will keep in mind that this is nothing but negative into sin theta minus cos theta. So whenever I'll write the second term, I'll be multiply a negative here. So I'll write sin theta minus cos theta, but for the second term, I'll write the negative. That will be multiplied. So now when I'll write this LCM, now I'll simplify the first term. Here see what are there and what is LCM. Only One sin theta is not here, so sin theta will be multiplied here, first term. So it will be sin cube theta. And for this it will be minus cos cube theta. मैं फिर से बता रही हूँ थोड़ा, तो हमने क्या क्या किया है यहाँ तक, साइन थीटा ऊपर ले गए, साइन स्क्वायर थीटा हो गया, कॉस थीटा साइन थीटा माइनस कॉस थीटा के साथ मल्टीप्लाई हुआ। हियर ऑल्सो कॉस स्क्वायर थीटा हो गया और साइन थीटा कॉस थीटा माइनस साइन थीटा के साथ मल्टीप्लाई हुआ। अभी हम जब सिंप्लीफाई करेंगे देखेंगे एलसीएम क्या है ना। एलसीएम एक साइन थीटा है वो लिख दिया, कॉस थीटा है लिख दिया, साइन थीटा माइनस कॉस थीटा और कॉस थीटा माइनस साइन थीटा दोनों एक ही है, एक में एक नेगेटिव कॉमन लेने से सेम आ जाएंगे। तो इसीलिए हमने क्या किया, एक को एलसीएम में लिखा और सोचा कि इसको जब लिखेंगे हम नेगेटिव मल्टीप्लाई कर देंगे, क्योंकि इसको मैं अगर लिखना चाहूंगी, मैं लिखूंगी कॉस थीटा minus sin theta is same as your minus sin theta into cos theta. That means एक sin theta cos theta जब ले गए, एक नेगेटिव यहाँ रह गया और जो यहाँ मल्टीप्लाई हुआ होगा। अभी हम देखेंगे इसमें क्या नहीं है, क्या मल्टीप्लाई होगा। अगर आप कंपेयर करोगे फर्स्ट डिनोमिनेटर को, एलसीएम डिनोमिनेटर को, सिर्फ यहाँ साइन थीटा नहीं है तो वो साइन थीटा यहाँ मल्टीप्लाई हुआ होगा, तो साइन स्क्वायर थीटा था, फिर एक साइन थीटा मल्टीप्लाई होगा, तो ये साइन क्यूब थीटा हो जाएगा। अभी सेकेंड में आएंगे, सेकेंड में एलसीएम में साइन थीटा है, कॉस थीटा है, साइन थीटा माइनस कॉस थीटा है, लेकिन यहाँ कॉस थीटा नहीं है तो कॉस थीटा मल्टीप्लाई होगा, लेकिन और क्या मल्टीप्लाई होगा, एक नेगेटिव भी मल्टीप्लाई होगा। क्यों ना, क्योंकि हमने कॉस थीटा माइनस साइन थीटा था, हमने साइन थीटा माइनस कॉस थीटा ले लिया था, तो यहाँ माइनस कॉस क्यूब थीटा होगा। तो ये क्वेश्चन थोड़ा ट्रिकी है, आपको स्टेप याद रखना है तो सारा चीज हो जाएगा। नेक्स्ट हम आएंगे क्या है ना, इसको फिर कैसे सिंप्लीफाई करेंगे, साइन क्यूब थीटा माइनस कॉस क्यूब थीटा, इसको हम सिंप्लीफाई करेंगे कि एक क्यूब माइनस बी क्यूब फॉर्मूला से। इसको थोड़ा लिख के रखिए, एक क्यूब माइनस बी क्यूब, एक क्यूब माइनस बी क्यूब का फॉर्मूला क्या है, थोड़ा मैं रब करती हूँ, रब करके लिखती हूँ, क्योंकि हमको ट्रिगोनोमेट्रिक आइडेंटिटी इसीलिए डिफिकल्ट लगता है। यहाँ ट्रिगोनोमेट्रिक रिलेशन भी लग रहा है, प्लस हमारा एल्जेब्रिक आइडेंटिटीज भी लग रहा है। अगर एल्जेब्रिक आइडेंटिटीज हमको याद नहीं है तो हमको डिफिकल्ट लगेगा। तो ए क्यू माइनस बी क्यू इज इक्वल टू ए माइनस बी इंटू ए स्क्वायर प्लस बी स्क्वायर प्लस ए बी, ये है ए क्यू माइनस बी क्यू का फॉर्मूला। तो साइन क्यूब माइनस कॉस क्यूब में हम उसको लगाएंगे, तो हम क्या लिखेंगे, हम लिखेंगे साइन थीटा माइनस कॉस थीटा इंटू साइन स्क्वायर थीटा, ए स्क्वायर साइन स्क्वायर थीटा, बी स्क्वायर कॉस स्क्वायर थीटा प्लस ए इंटू बी साइन थीटा इंटू कॉस थीटा। नीचे लिखते हैं जो है, तो नीचे है साइन थीटा कॉस थीटा साइन थीटा माइनस कॉस थीटा। अभी देखेंगे हम क्या क्या कट जा रहा है, साइन थीटा माइनस कॉस थीटा पूरा ये कट गया। फिर हम सिंप्लीफाई करते हैं, साइन स्क्वायर थीटा प्लस कॉस स्क्वायर थीटा ये होता है 1, तो 1 प्लस साइन थीटा इंटू कॉस थीटा बाई साइन थीटा कॉस थीटा। अभी थोड़ा राइट हैंड को साइड को देखेंगे हम कहाँ तक पहुँच गए। राइट हैंड साइड में है 1 प्लस सेक थीटा इंटू कोसेक थीटा, दो टर्म है, यहाँ हमको एक मिल रहा है तो हमको दो बना देते हैं। एक लिखते हैं 1 बाई साइन थीटा कॉस थीटा, 1 के नीचे एक बार लिख दिया, एक बार लिख दिया साइन थीटा कॉस थीटा के नीचे साइन थीटा कॉस थीटा। हमको दो चाहिए तो इसलिए दो बना देते हैं, हो गया। अभी ये क्या हो गया, ये कट के जो सेकंड टर्म ये पूरा 1 हो जाएगा, सेम चीज है, खाली नीचे वाला फर्स्ट वाला रहेगा। अभी ये क्या है ना, ये है 1 बाई साइन थीटा, ये और क्या है 1 बाई कॉस थीटा। क्यों मैं अलग करके लिख रही हूँ, क्योंकि मुझे सेक थीटा कोसेक थीटा लाना है, I have to bring sec theta into cosec theta. So ये 1 plus 1 by sin theta is cosec theta, 1 by cos theta is sin theta. If you can understand that it will be sec theta into cosec theta, no need of converting what I am writing. You can write directly 1 plus sec theta into cosec theta. So this is equal to RHS, hence proved. Next question number 4. 1 plus sec a by sec a is equal to sin square a by 1 minus cos a. Hence is given, simplify LHS, RHS separately. That means you simplify LHS for some steps, RHS for some steps, then you will show that they are equal. So let me start from LHS. 1 plus sec A by sec A. Can you guess what to do? Of course, we will change sec A into cos, because in the right hand side there is no sec, no cosec. So I'll write 1 plus 1 upon cos A. Sec A is 1 upon cos A, if you'll recall the relation, by 1 by cos A. Then in the numerator I'll simplify. Cos A is LCM. So this will be 1 plus cos A. 1 will be multiplied here upon 1 by cos A. So this will be how much? 1 plus cos A by cos A multiplies cos A into 1. So this 2 will be cancelled. It is 1 plus cos A. LHS. Now coming to RHS, because it cannot further simplified. RHS is sin square A by 1 minus cos A. We are getting all cos A on the left hand side. So I'll change this sin square A. How to change? It is 1 minus cos square A. What is factor of 1 minus cos square A? Same concept, x square minus b square is a plus b into a minus b. So I'll put 1 plus cos A multiplies 1 minus cos A. And here is 1 minus cos A. So cancel, what you are getting? 1 plus cos A. So LHS is equal to RHS. Hence verified. Hence proved. Question number 5. Cos A minus sin A plus 1 by cos A plus sin A minus 1 is equal to cosec A plus cot A using identities cosec square A minus is equal to 1 plus cot square A. You have to apply these identities. You have to prove. How will you get cosec? I'll get cosec if I'll get 1 by sin A. I'll get cot cos by sin A. So that means for the left hand side, I'll convert this into your cot and cosec. To cot and cosec, I'll divide throughout by sin A, all the terms. So LHS is equal to cos A minus sin A plus 1 upon cos A plus sin A minus 1. This was given. I'll apply, or I'll convert this into cosec and cot. So throughout I am dividing with sin A, because cos A divides sin A, I'll get cot. So what I'm writing, cos A by sin A minus sin A over sin A plus 1 by sin A. All the terms in the numerator I divide with sin A. Then I'll go for denominator. Cos A by sin A plus sin A upon sin A minus 1 upon sin A. Let us see what I made. I made cot A minus 1 plus cosec A upon cot A plus 1 minus cosec A. After getting cot A, cosec A, now it is saying that use these identities. Cosec square A is equal to 1 plus cot square A. That means what will be 1? 1 will be cosec square A minus cot square A. So I will change the numerator 1 to cosec square A minus cot square A only in numerator, only in numerator, not in denominator. So what I'm writing? I'm writing this will be, I'm writing here only to make use of space, cot A plus cosec A I took together. For minus 1, I am changing as cosec square A minus cot square A. Please note down this step very carefully, because without this step you cannot follow this answer steps. What I do, I did cot A cosec A I took together, and this minus 1 I took to the right side, and here I am applying cosec square A minus cot square A for 1, and no change in the denominator as it is. So it will write cot A plus 1 minus cosec A. Got it? Then you know that I'll apply algebraic identities. A square minus b square. So a square minus b square is a plus b into a minus b. So cosec A plus cot A into cosec A minus cot A. So I'll write cot A plus cosec A. Within bracket, I'll change it to factors. So this will be cosec A plus cot A into cosec A minus cot A. Upon how much? Cot A plus 1 minus cosec A. Now see, within bracket I am getting another cosec A plus cot A. Here one is cosec A plus cot A. So whole cosec A plus cot A I'll take common. Cot A plus cosec A I'll take common. So for the first term, it will be left only 1. And what will be left here? Within bracket, I'll get a cosec A, I'll get a minus cot A. And denominator is cot A plus 1 minus cosec A. So next is simplify within the bracket. Cot A plus cosec A, 1, cosec A will be negative, cosec A will be negative, cot A will be positive. Cot A will be positive. Are you getting the same term as your denominator? Cosec is negative, cot is positive, 1 is positive, cot y is positive, 1 is positive. So these two terms will be cancelled. So what you are getting? You are getting cot A plus cosec A. So which is in your right hand side. So hence proved. तो इस क्वेश्चन में कहाँ चेक करना है? पहले हमने कोसेक में कन्वर्ट कर लिया, साइन में डिवाइड करके कॉट और कोसेक में, फिर हमने 1 को चेंज किया सिर्फ न्यूमरेटर में, डिनोमिनेटर में नहीं, डिनोमिनेटर में एज इट इज 1 को चेंज किया कोसेक स्क्वायर माइनस कॉट स्क्वायर करके, फिर हमने ए स्क्वायर माइनस बी स्क्वायर फॉर्मूला लगाया, कोसेक ए प्लस कॉट ए, कोसेक ए माइनस कॉट ए, फिर हमने ये जो कोसेक ए प्लस कॉट ए दोनों से कॉमन ले लिया बाहर, तो यहाँ 1 ही रह गया, और यहाँ क्या रह गया, कोसेक ए माइनस कॉट ए रह गया। अभी उसके आगे माइनस है तो कोसेक नेगेटिव हो गया, कॉट पॉजिटिव हो गया। अभी देखेंगे तो ये टर्म क्या डिनोमिनेटर के साथ इक्वल हो गया, ये दोनों को काट दिया तो कॉट ए प्लस कोसेक ए रह गया। नेक्स्ट इज सिक्स्थ क्वेश्चन। Prove that 1 plus sin theta by 1 minus sin theta is equal to sec theta plus tan theta. ये बुक में, in book it is given 1 plus sin a by 1 minus sin a. This is the same thing. A theta does not make any difference. So when the question is the square root of this cos sec theta plus tan theta, so what you will do, you will rationalize. What is the meaning of rationalize? As same as your algebraic identities. Okay, that means I'll rationalize the denominator. That means I'll multiply it with its conjugate. What's the conjugate? Multiply with conjugate multiplication. What is conjugate? Conjugate is if it is 1 minus sin theta, multiply with 1 plus sin theta. If it is 1 plus sin theta multiplied with 1 minus sin theta, both in numerator and denominator. This is the rationalization. So I'll start from LHS. I'll write 1 plus sin theta into 1 by 1 minus sin theta. I'll multiply its conjugate, means 1 plus sin theta both in the numerator and in denominator. This is the step. This is the step to note. This is the trick of solving this question. यहाँ minus है, you have to multiply plus both in the numerator and denominator. If it would be positive here, we will multiply negative both in the numerator and denominator. Then what you are getting in the numerator, you are getting a square. And in the denominator, you are getting 1 minus sine square theta. See, just algebraic identities. A plus b into a minus b. And 1 plus sine square theta, again square root, you will get 1 minus sine square sine theta. What I am doing, x square root. This is same as x. And here I am getting square root of your cos square theta, square root. 1 minus sine square theta is how much? Cos square theta. Cos square theta and square root, it will be cos theta. So this will be 1 plus sine theta by cos theta. Then check once the right hand side. It is sec theta plus tan theta. That means there are two terms. Here I am getting one term. How to do it? I'll make into two. One is 1 by cos theta plus one is sine theta by cos theta. Both the cos theta I'll take with 1 as well as sine theta by cos theta. 1 upon cos theta is sec theta. Sine theta upon cos theta is tan theta. So I am getting RHS. I am coming to one more question of similar type. I hope you can proceed now without seeing the screen. What we'll do? LHS multiply with opposite of the denominator. We say it's conjugate 1 plus sine theta. What I'll multiply? I'll multiply 1 minus sine theta both in the numerator and denominator. In the numerator, I'll get 1 minus sine theta whole square. And here I'll get 1 minus sine square theta. 1 minus sine square theta is equal to cos square theta. It will be sine, not cos. 1 minus sine theta whole square. it will be cos square theta. So if we take square root, it will be 1 minus sin theta by cos theta. Then what next? Make it 2, 1 by cos theta minus sin theta by cos theta. So you are getting sec theta minus tan theta. This is equal to RHS. Proved. Another one question of similar type. So I am doing very quickly. 1 minus cos theta by 1 plus cos theta. This is LHS. I'll multiply with conjugate. So what I'll get? 1 minus cos theta. 1 minus cos theta will be multiplied in both the numerator and denominator. So in the numerator I'll get a square. Denominator I'll get 1 minus cos square theta. A plus b into a minus b. Here I am getting 1 minus cos theta whole square. In denominator I am getting sin square theta. I'll take the square root. In the numerator I am getting 1 minus cos theta, and in denominator sin theta. Again I'll make it 2 because there are two terms. 1 by sin theta minus cos theta by sin theta. 1 by sin theta is equal to cosec theta, and this is equal to cot theta, is equal to RHS, hence proved. So I hope you can do yourself. This is your homework to do yourself. So these are the 4 questions you can do yourself now, and see these 4 questions. You can find a relation between them. This was a square. It was 1 plus sin theta by 1 minus sin theta. Same question, it is under root. That means don't think they are different. One question can be written in another form. The same question, square root is this. It is square. You have proved this. Square root is this. So always make a relation between the questions so that you can proceed in a nice way, and the question will not be seen unfamiliar to you. So not only do the text question, you can do some more questions, because identities is, there is no limitation in identities. So I hope you have learned, you have built some confidence. So next time we'll go for rest textbook questions, and keep on subscribing, keep on liking, keep on your sharing the video.